This question says that cyclohexane undergoes molecular rearrangement in the presence of aluminum chloride to form methyl cyclopentane, or MCP, according to the following equation. If Kc equals 0.143, and this describes our system at equilibrium, at 25 degrees Celsius for this reaction, predict the direction the reaction will shift if the initial concentrations of cyclohexane and MCP are 0.2 molar and 0.1 molar. So in order to think about this question, a lot of the times when you're asked about how a reaction will shift, we're going to be thinking about Le Chatelier's principle and comparing the state of the system that we're interested in to the state of the system at equilibrium. And we always want to know, how does the system get back to equilibrium? So in order to do that, I'm going to calculate Q for the initial state of the system, and I'm going to compare it to this K that we have here. So to find Q, this is just going to be the initial concentration of our MCP, which is our products, over the concentration of our reactants, which is just our cyclohexane. And we were given this information. It is 0.1 molar and 0.2 molar. And we get that QC is 0.5. So looking back at KC, we can say that Q is greater than K. So this is our second point. So this just means that there's more products present initially than at equilibrium, because to make Q bigger than K, we need more MCP, or more products. So we must consume some of those products to go back to an equilibrium state. So to do that, we're going to shift to the left to make more reactants and get closer to our value of K at equilibrium. And I would definitely know how Le Chatelier's principle works for different situations for this exam. For instance, if you add heat to a reaction, how is that going to impact the reaction? Is it going to shift to the products of the reactants? That depends on if the reaction is endo or exothermic. How will your system change if you increase the pressure, for instance? These are some good things to go over for the exam.